Iron ore. You don't eat it, you don't drink it, but you can't live without it. This unassuming mineral is the cornerstone of modern civilization. Without it, the world as we know it would come to a grinding halt. From the tallest skyscrapers to the simplest tools, iron ore is the unsung hero that makes it all possible. It's the main ingredient in steel, and steel is everywhere. Imagine a world without steel. No cars, no buildings, no bridges. Even the smallest things, like the nails that hold your furniture together, would be impossible without steel. And steel, in turn, would be impossible without iron ore. Steel production is a complex and fascinating process. It starts with iron ore, which is smelted in blast furnaces at incredibly high temperatures. The molten iron is then mixed with carbon and other elements to create different types of steel, each with its own unique properties and uses. Cars, buildings, bridges, even your kitchen sink, all made possible by iron ore. The versatility of steel means it can be found in almost every aspect of our daily lives. From the vehicles we drive to the homes we live in, steel is an integral part of our world. Now, iron ore isn't found lying around in shiny piles, it's buried deep inside the earth, hidden in rocks. Extracting it is no easy task. It requires advanced machinery and skilled labor to locate and mine the ore. It's buried deep inside the earth, hidden in rocks. The process of mining iron ore involves drilling, blasting, and hauling the ore to the surface. It's a labor-intensive and time-consuming process, but it's essential for the production of steel. Getting it out, well, that's a dirty job. Miners work in harsh conditions, often covered in dirt and grime. They use heavy machinery to break through the rock and extract the ore. It's a tough job, but it's a necessary one. But somebody's got to do it. These men and women are the backbone of the mining industry. They work long hours in difficult conditions to ensure that the iron ore is extracted and processed. That's where the miners come in. They are the unsung heroes who make it all possible. Without their hard work and dedication, the production of steel would come to a standstill. These men and women work tirelessly in some of the harshest conditions imaginable to extract the ore that makes our modern world possible. They face numerous challenges, from the physical demands of the job to the risks associated with working underground. It's a tough job, but it's an important one. The determination and resilience of these miners are truly remarkable. They are committed to their work, knowing that their efforts are crucial to the production of steel. And it's just the first step in a long and fascinating journey from rock to steel. Once the ore is extracted, it is transported to factories where it undergoes a series of processes to become the steel that is used in countless applications around the world. The journey of iron ore from the depths of the earth to the structures that shape our world is a testament to human ingenuity and perseverance. Finding iron ore is like finding a needle in a haystack, except the haystack is a mountain and the needle is a rock. The process begins with geologists, who are the detectives of the natural world. They study the Earth's crust, looking for clues that indicate the presence of iron ore. This involves analyzing rock formations, soil samples, and even the magnetic properties of the ground. Geologists use special tools and techniques to locate these valuable deposits. They might use a hammer to break open rocks, a compass to navigate the terrain, and sophisticated instruments to measure the magnetic fields. These tools help them pinpoint the exact location of the iron ore. Once a deposit is found, it's time to get digging. The discovery of iron ore is just the beginning. The next step involves planning the mining operation, which includes determining the best method to extract the ore, ensuring the safety of the workers, and minimizing the environmental impact. There are two main ways to mine iron ore: open pit mining and underground mining. Each method has its own set of challenges and advantages. The choice between them depends on the depth of the ore, the geology of the area, and economic considerations. Open pit mining is like digging a giant hole in the ground. This method is used when the ore is located relatively close to the surface. It involves removing large quantities of earth and rock to expose the ore beneath. It's used when the ore is close to the surface. The process starts with clearing the vegetation and topsoil, followed by drilling and blasting to break up the rock. The broken rock is then transported to a processing plant where the iron ore is separated from the waste material. Giant machines like excavators and dump trucks remove layers of earth and rock to get to the ore. These machines are capable of moving thousands of tons of material each day, making the process efficient and cost-effective. Underground mining is used when the ore is buried deep. This method involves creating a network of tunnels and shafts to reach the ore deposits. It's a more complex and expensive process compared to open-pit mining, but it's necessary when the ore is located far below the surface. Miners dig tunnels and shafts to reach the ore, using a variety of tools and machinery. The tunnels are reinforced with supports to prevent collapses, and ventilation systems are installed to ensure a supply of fresh air, which is then brought to the surface. The extracted ore is transported to the surface using lifts or conveyor belts. Once at the surface, the ore undergoes further processing to remove impurities and prepare it for use in various industries, from construction to manufacturing. The iron ore that comes out of the mine is in big, chunky pieces, not very useful for making cars and bridges. That's where the crushing process comes in. First, the ore is fed into a machine called a jaw crusher. This beast has two big metal plates that smash the ore into smaller pieces. Think of it like a giant nutcracker. Next, the ore goes through a series of crushers and screens. Each machine breaks the ore down further until it's the size of marbles. This process is loud, dusty, and absolutely essential. Crushed ore is a mixture of valuable iron and waste material like rock and dirt. We need to separate the good stuff from the bad. How do we do that? With magnets. Iron is magnetic, so we use giant magnets to pull the iron ore particles away from the waste. The waste material is discarded, while the iron ore continues its journey. This process is called magnetic separation, and it's a marvel of engineering. It's like a giant sorting machine, separating the wheat from the chaff. Section 5. The blast furnace. Turning rock into metal. We've crushed it, we've separated it, now it's time to melt it. The iron ore, along with coke, a type of coal, and limestone, is fed into a blast furnace. A blast furnace is a towering structure that reaches hundreds of feet high. Inside, temperatures can reach over 3,000 degrees Fahrenheit, hot enough to melt steel and then some. The intense heat causes a chemical reaction that separates the iron from the oxygen in the iron ore. The result? Molten iron, also known as pig iron. Section 6. From pig iron to steel, refining the metal. Pig iron is strong, but it's also brittle. To make it more useful, we need to refine it into steel. This is where things get really interesting. The molten pig iron is poured into a giant container called a basic oxygen furnace. Oxygen is blown into the furnace, which burns off impurities like carbon, silicon, and manganese. The amount of oxygen determines the type of steel produced. Want strong, durable steel for bridges? Add more oxygen. Need flexible steel for car bodies? Use less oxygen. It's all about precision and control. Section 7. The many faces of steel. Steel is like a chameleon. It can take on many forms. By adding different elements to the molten steel, we can create a wide variety of alloys, each with its own unique properties. For example, adding chromium creates stainless steel, which is resistant to rust and corrosion. Adding nickel makes the steel stronger and more resistant to heat. The possibilities are endless. This versatility is what makes steel such an important material in our modern world. Section 8. Steel, the unsung hero of our lives. From the skyscrapers that pierce the clouds to the surgical instruments that save lives, steel is everywhere. It's the unsung hero of our modern world. Think about it. Without steel, we wouldn't have cars, airplanes, or trains. We wouldn't have bridges, tunnels, or skyscrapers. Our world would be a very different place. So next time you see a steel structure, take a moment to appreciate the journey it took to get there. From the mines to the mills, it's a testament to human ingenuity and hard work. Section 9. The future of iron. The demand for steel is only going to increase in the coming years. As we look ahead, it's clear that steel will continue to be a cornerstone of modern civilization. From the towering skyscrapers that define our cityscapes to the intricate networks of bridges and tunnels that connect us, steel is everywhere. It's in the cars we drive, the appliances we use, and even in the devices we hold in our hands. The versatility and strength of steel make it an indispensable material in our daily lives. As populations grow and economies expand, we'll need more steel for buildings, infrastructure, and transportation. Urbanization is accelerating at an unprecedented rate, with more people moving to cities every day. This urban growth demands robust infrastructure, from high-rise buildings to extensive public transportation systems. Steel is the backbone of this development, providing the structural integrity needed to support such massive projects. Moreover, As we push towards more sustainable and efficient transportation solutions, steel will play a crucial role in the construction of electric vehicles, high-speed trains, and other innovative transit systems. But the future of iron isn't just about quantity, it's also about sustainability. As we become more aware of our environmental impact, the steel industry is under pressure to reduce its carbon footprint. Traditional steel production is energy-intensive and generates significant emissions, but the industry is evolving. New methods and technologies are being developed to produce steel in a more eco-friendly manner. This includes using renewable energy sources, recycling scrap metal, and adopting cleaner production processes. The goal is to create a circular economy where steel can be reused and recycled indefinitely, minimizing waste and conserving resources. We need to find ways to produce steel more efficiently, using less energy, and producing fewer emissions. Innovations such as electric arc furnaces, which use electricity to melt scrap steel, are already making a difference. These furnaces are more energy efficient and produce fewer emissions compared to traditional blast furnaces. Additionally, advancements in material science are leading to the development of stronger, lighter steel alloys that require less material to achieve the same performance. This not only reduces the amount of raw material needed, but also lowers the overall energy consumption and emissions associated with steel production. The good news is that the industry is up to the challenge. Researchers and engineers are constantly exploring new ways to make steel production more sustainable. Collaborative efforts between industry leaders, governments, and academic institutions are driving innovation and accelerating the adoption of greener technologies. Pilot projects and large-scale implementations of these new methods are already showing promising results, paving the way for a more sustainable future for the steel industry. New technologies are being developed all the time to make steel production more sustainable. From hydrogen-based steelmaking processes that eliminate carbon emissions to advanced recycling techniques that maximize the use of scrap metal, the future of steel production is being reshaped by innovation. These technologies not only help reduce the environmental impact of steel production, but also improve efficiency and cost-effectiveness, making sustainable steel a viable option for industries worldwide. The future of iron is bright, and it's going to be made of steel. As we continue to innovate and adopt more sustainable practices, steel will remain a fundamental material in building our world. The advancements in steel production technology and the commitment to sustainability ensure that steel will not only meet the demands of the future, but also contribute to a greener, more resilient planet. The journey ahead is challenging, but with determination and ingenuity, the steel industry is poised to lead the way towards a sustainable future.